So I'm just going to talk out things I think you should be saying to yourself. You don't have to know what a terrace is to recognize that you're above the ground 15 meters. Bless you. Should kind of be clear the ball's being kicked at an angle. Your picture should represent that. I think you should put things in there like the angle and maybe the speed, and maybe go so far as to say how high above the ground you are. I think it's helpful to have maybe something that tells you what the picture of this looks like. Now, I've heard from a lot of folks that they are confused. When I heard the phrase yesterday in a different class, the person didn't know I heard him say this, and I don't know who they are. Do you have any idea what's going on in physics? Well, I'm hoping you have some idea. But here we go. Is there anything wrong with the chart I've drawn or the picture I've drawn? If you can't get this far, we got troubles. Have you decided what direction you're going to make positive? I think it's a good idea to just, when you're drawing your picture, to just be clear and identify for everybody, including the person who's grading your paper, what direction you're making positive. And if you're trying to take notes, did you write down some notes just now to make sure that you have in your notes the things that have to happen? Or are you looking at a page that already tells you the things you need to do to make sure you have them all? Can you identify what's been given from the text of the problem? Like delta y is 15. Now, this is only true when we're talking about the trip from the top of the building to the ground. Question C and D are going to change that. It's a different situation. You have to know when the situation is changed. So the first two questions are asking about the trip from the top of the building to the ground. But the second two questions are asking about the top of the building to the top of the flight. That's a different problem. So I am right now identifying A and B as the parts of the problem I'm attempting to solve. It's not always obvious where the break in a problem is, but I think it's kind of obvious in this one. Now, Vy naught is kind of a prescribed thing for you to do now. That's going to be 12 sine 30 degrees, which should be 6. If it's not 6, your calculator's in radians. The acceleration is going to be 10 meters per second squared. And a horizontal velocity is 12 times the cosine of 30 degrees. I don't know what that is.
10.4.
Okay, 10.4 meters per second. Now, I do this every time, but you guys tend to be in a hurry and you just kind of blindly do it. I evaluate up and down. I stop every time. You think I'm doing this because I don't think you guys are very smart. That's not it at all. I'm doing this because I know what we're covering next, and I know how hard it is to do this in the next part of the things we're going to cover. So being deliberate here will make all the difference in the world. Ask yourself the direction of each of these things and assign positive and negative. We've been doing it now, we're complacent because we always think up is positive and down is negative. And because of that complacency, it will not serve us when we do our next unit. So just ask yourself those questions. Be mindful and be deliberate. Now, you have to find the time. You need a method to find the time. This isn't physics. This is looking for an equation. This is math. And you have two different possibilities. Right now, what I'd like to do is take a pause here, walk around the room, and see that everybody solves for the time. You're going to get two of them. One of them's the right answer and one of them's the wrong answer, and it'll be obvious which is which. So I need to know whether you can do this part or not, because we can't go on unless you can. So when I walk around, I want you to point at it. And if you can't do it, either talk to a friend or talk to me about it. So once we have our time, using the quadratic formula and a motion equation, we use our time to figure out the horizontal movement of the object. And in this case, that's just going to be that 10.4 times 2.43. And I don't know, probably close to 25, I hope. So I'm just going to put meters. I'm a little exasperated, but not terribly so. Now that answers A and B. That is a full projectile problem, and yeah, it has all the nasty math that you have to do. C and D are not as hard. So let's talk about C and D, because they are different though. You can't use all the things that are here. Let's reevaluate what C wants. C wants to know what's the maximum height attained by the object. In your notes, this should be big. It should be highlighted. It should be in a box, because we've talked about it a bunch of times. But maximum height is when final velocity is 0. Period. But that means you got to erase this 15. That's no longer true. It's not going to go delta y 15. And the time is no longer 2.43. I don't know how long it's going to take to get there. It's going to be less than 2.43, I promise. The horizontal velocity and the vertical velocity start the same though. So question C is a new problem entirely, because it's a different displacement. Something different is in the problem. So now, because we're going to deal with this different change, we're going to change our problem to be C and D. C and D refer to the same situation. They refer to this point right up here at the top. Now this one, well within your purview. You have to figure out what delta y is. And you have all of this to choose from. You can leave out t entirely. That's going to be this Vy squared minus Vy naught squared equals 2a delta y. There's all the stuff in it I want to use. You've got to be careful about signs here. Vy is 0 minus that 6 squared equals 2 times negative 10 times delta y. Now here's where people make mistakes, so let's make sure we emphasize this. This is going to tell us delta y. Right, 36 divided by 20, so 1.8. Now here's the issue. Our answer is not 1.8. This is not the answer to the question. This is delta y, but it asks for what maximum height above the ground. So you need to add 15 to this, because this gave us the height above the terrace, not above the ground. I know it's silly, and you might think, oh, I just forgot something small. Believe it or not, that's actually more important than all the math we've done today. Knowledge that delta y told you how high from the starting point the object reached, and that you have to bring to the reality of the problem here, that the object didn't start on the ground, that I need to add the 15 meters so I know that's how high in the air it was. That's actually intuition, and it's harder. It's harder to get students to do that part than it is to get them to do 1.8 meters. You guys are excellent at just plugging stuff into an equation and getting a number out, but less good at evaluating what's really happening. So the right answer has got to be 16.8 meters. I know it sounds like no big deal. That's actually quite a big deal to me. You'll get more points knowing that on the exam than you will figuring out which equation to use. This next part's harder though, and a lot of students have a difficult time with it. We want to know where on the ground this is. This is a time problem again. We need to know when the object makes it there. It's not hard, but we have to do the projectile part of this again. We have to figure out the time and then use it to figure out how far horizontally it's gone. So anytime we're dealing with horizontal that's connected to vertical, you've got to connect them through the time. There's no other way to do it. So I'm going to figure out how long it's in the air for. I'm going to say Vy equals AT plus Vy naught. So 0 equals negative 10t plus 6. I'm pretty sure, boy, nobody can see the red, can they? No one in the back can see the red, that's for sure. I can barely see it, and I'm standing right next to the freaking board. Just go back to dry erase markers. I like them better anyways. So, what is that? 0.6?
Yeah.
So, not done yet. We got to put 0.6 here. And then figure out what delta x is. 10.4 times 0.6. So it looks to be like, 6 meters.
6.2.
Excellent. 6.2?
Yep.
This is how far along the ground. Now, just looking at this and looking at your notes are a disaster, aren't they? You got all that stuff with quadratic formula on it and all that kind of thing all over the place. Take a moment. I would write somewhere, if you wrote this problem down, somewhere I'd write A, B, C, and D. What did you have to do for each one of those things? Just a sentence. A sentence will do. When I say you can use your notes for this, do you have anything of value in that folder that you can open up to? Right now, put it in there. Have it sitting there. For A, you had to figure out the time from the Y information using a motion equation. Perhaps using the polynomial root finder. Hell, that's a thing. That's going to become the thing. How far away? You have to deal with the range then. C, maximum height, that's when Vy is 0. You have to reset the problem, set Vy to 0, and solve for delta y. And don't forget to add the distance from the ground. Put that in there. Highlight that. Make sure you don't do that. You don't want to do that on the test. You want to get that point. You guys say I just made a lot of silly mistakes. We're not going to make these stupid, silly mistakes. To figure out where it makes it to that maximum height, you have to find out how long it takes to make it to that maximum height. That means finding the time again. The time when Vy is equal to 0. It's so tedious and so meticulous. Now, here's the part you don't want to hear. We've spent 25 minutes doing this, actually a little bit longer. This problem needs to be like 5-6 minutes. It's long because you're having to find the time for the roots. That's what's making it long. So I understand that and I respect it, but I also want you to know that it's got to be sped up. This could be a multiple choice question. It's unlikely, but it could be. I hate to think they put this as a multiple choice. So, I think you should try one again. Think that's not unreasonable? Yes, sir.
For C, we're finding the max height.
From the very beginning again. I'm saying it like that because I recorded first period and I'm kind of redoing the same problem again. Second period, and it's not a new recording. So if I ever post this video, somebody's going to wonder why we started all over again. I think it's in your best interest to draw a picture. Not because I think it's super necessary for everybody, but because in our next unit, you have to draw pictures. You'll be graded on them. So get used to drawing a picture. It's just a schematic. It doesn't have to be all that interesting. The idea is that you understand a little bit about what's going on. And it will help with one of the questions we're going to have here in just a minute. Now, when you're doing this, keep in mind that we are looking for where it landed eventually, but that's not the only thing that of value here. There are two separate questions here. They refer to different things. The first question is about the entire trip from the top of the building to the ground. But the second two questions aren't. The second two questions are about the launch and the maximum height, which is a different trip. It's a different time. It's a different everything. So we're going to start this problem by looking at A and B. They are not directly related to C and D. Every one of these problems, though, still tracks the same group of things. And you have to kind of be aware of where to put them. Now, some of this stuff is pretty easy. The object lands 15 meters below where it started. We're kind of told that. And the picture kind of bears that out. This is 15 meters. The initial y velocity, it's prescriptive, meaning you have a prescription on how to get it. It's going to be 12 times the sine of 30 degrees. So it's 6. We don't have the final velocity, so I'm not going to worry about it. But we do know that it's being accelerated by gravity, 10 meters per second squared. Horizontally, well, I still have the launch velocity. That is prescriptive too, 12 cosine 30 degrees, which I think is like 10. 10.4 maybe, 10.6, I can't remember. Now, most students don't think to do this next, but you really need to, especially with where we're going next. You need to assign direction. And you need to be deliberate and obvious. Look, on your test, draw the picture, draw in a little thing that tells me what direction you're selecting for positive. Make sure the person grading your test can see it. That will make sure you also take a moment and identify what's going up and what's going down. Trust me, it's complacency now because up and down is pretty obvious to you. Our next unit, it will not be like this. Assigning direction is critical or you'll never get anything right. Now, the next part is just math. It's not physics. It's just plugging it into equations and spitting out numbers. It's recognizing that we need the time here, that's the important value. How you get it doesn't really matter. Quadratic formula, fine. Finding the final velocity first and then getting the time, excellent. Plugging it all in your calculator and having it do the work, excellent. I don't really care. But we get 2.4 seconds. That's the time. Part of the issue is making sure all of your signs are right. One of the number one mistakes that was being made, and the reason why you got the wrong time, was having the signs for these things wrong. And doing algebra incorrectly. There's quite a few people who, when they tried to do this, screwed up the sign here in their quadratic formula. Screwing up one of these signs screws up the quadratic formula. If you screw up this one, it flips the two roots. The one that's positive becomes negative and vice versa. We don't care about the negative root. But if you have two positive roots, you should stop and think about it. This one, remember, tells us when it reaches the ground. You get a negative root because math likes to have symmetry and it completes the parabola. That's why you get a negative root. It says if you could go back in time, you would have been underground back here. That's what it's saying. And that's why you get this negative time. You can't go back in time. That doesn't make any sense. But it is possible. I believe the rest of this is not hard. And I think most of you understand what happens next, that you're going to take this over here, plug it in for the time, and then you're going to multiply those two things together and figure out what the displacement is. So I don't think this one was particularly hard once you kind of put that together. 10.4 times 2.4, so you get like 25 meters. Questions about that part? The next part's completely different. So if we're good here, when I actually ask you to move on to questions C and D, things change. And you have to be aware of what that means to go on to C and D. None of this necessarily stays the same. It's asking a different question. But not all of it has to be redone. C and D asks about the maximum height achieved by the object. In your notes, you had better have it big and bold what that means. If you don't, you haven't written it down yet, don't know what you're waiting for. Maximum height is achieved when the y velocity is 0. It should be already in your notes. If it's not, put it in there. Emphasize it. Now, you're going to make some mistakes here, but solving for how high it is means solving for this value. Figuring out what the delta y is now when its velocity is finally 0. Now, that part's not tough. You can do that. You've proved it. We've already passed that test. So take a quick second. I want to walk around and see who can tell me what delta y is. And a few of you who are shrewd realize that the answer to question C is not delta y. If you're paying attention, you understand that. If you're not paying attention, you don't. So let's go with 60 seconds to tell me what delta y is. All right, so a variety of things out there. But one of the things that is you've got to break away from is C and D are different problems from A and B. What we are doing does not rely on the information from A and B. Some of it will be reused, but you'll notice we reset things, so you can't use the time anymore. The time we solved for was the time to go from here all the way to the ground. The maximum height will not be there. The maximum height will be like right here. So we can't use the 2.43 seconds anymore. And yes, this is the kind of thing I need you to be putting together. You have to be putting it together. You need to write something down now. For all of you who didn't understand or said, I don't know where I was going, you need to write something down. That this object is going to be traveling from the starting point and some point right around here. It will no longer be going up or down. In that instant, its velocity is 0. That's the spot that we're interested in. Now, it's still moving. Its horizontal velocity is still 10. But it's no longer going up or down. So we're setting the y velocity to 0. And then you have to find a relationship, and you can't have one that has time in it. So you got to get all of those things right. So we're going to get Vy squared minus Vy naught squared equals 2a delta y. That's the one. 0 minus 6 squared equals 2 times negative 10 delta y. You don't make negative 6 positive 36 after you square it. The negative sign is part of the equation. It's not inside the variable. So some of you are believing you have to do this, and that's not true. In fact, it's expressly this. Now, if the y velocity were negative, you'd put a negative sign in here, but it wouldn't matter. No matter what you put in there, when it's done, the number will be positive, and you subtract it from 0, or you subtract it from whatever this is. So this is going to end up being 6 squared, and 0 minus 6 squared is negative 36. Which is good, because I'm going to have 2 times negative 10 here. Which means delta y is positive 1.8. That is not the answer to question C. Everything we've done here is correct. It's not the answer to question C. And here's where you really need to understand that there's parts of this that are about physics and parts that are about math. This, getting to 1.8, that was math. It's worth a point to me. It's worth a point that you figure out which relationship works, and it's worth a point for you to figure out, the math part. It's the least amount I can give to that. It's worth more points that you put everything where it's supposed to go, and that the signs are right. But understand, that's not the answer to the question. Because you're supposed to know the definition of delta y. I told you guys, definitions are weird in this class. Delta y is the change in position. It's a displacement. And the object started at the top of the building. What you just found was this height right here. That's delta y from the launch. Is that how high above the ground the object is? No, because it started 15 meters above the ground. If you want the answer, you've got to add 15 meters to it. That's actually the physics part. That's understanding the difference between what your equation tells you and what's being asked of you. That's worth more to me. I'll give that 2 points to understand that you know delta y is different than the question that's being asked. So many of you are going to put, and if it's a multiple choice question, yeah, 1.8 is going to appear as one of the multiple choice answers. Definitely. You understand why now, right? Even so, the next part, figuring out where it makes it to this point, we're talking about like this location on the ground. Where would you stand? It'll be above you at its maximum height. That's a projectile problem. You need to know when it's going to make it to that height. The only time you can actually figure out the horizontal stuff is if you know how long it's been moving for. So if you want to know where is the ball along the ground when it makes it to its maximum height, you'll have to figure out at what time it makes it to its maximum height. That still goes right back to projectile motion. Now, I want you to do that. I want you to take a minute and practice that so you can figure out where that is. But it would be more important and better for you if you wrote down what has to happen for you to get that answer. So that you understand these 4 things are what I'm going to expect out of you on the test. You should write down what you need to do for A, B, C, and D so you can get the right answer. C, you have to find delta y when Vy is 0, and then add it to the original height. Put every step down in there so you know. That way, if I say you can take your notes out for the last couple of minutes, there's something there to tell you things. But for question D, you need to figure out when it's at its maximum height. You need to do Vy equals AT plus Vy initial. This will tell you when it's at its maximum height. I got to put 0 in for Vy because that's the moment it's at its maximum height when it's no longer going up or down. Put in my negative 10t plus, and then this has to be whatever my initial velocity was, which is 6. This will tell me when it's at its maximum height. Knowing that you have to figure out the time, that's big to me. That's worth points. Figuring out the time, that's not as big to me. That's worth fewer points. But knowing that becomes 0.6 right here, ooh, that's big. That's important. And then multiplying those 2 things together to get, I don't know what it's going to be, 6 meters, 6.2 meters. I mean, the number part really doesn't matter to me that much. I want you to know that's how you get it. But again, doing math, not important. Knowing that the time applies to the horizontal side, more important. Look, if you don't get one number answer, but you write down all the things that you have to do to solve the problem, you will get more credit than a student who tries the number stuff and gets all the number stuff wrong and spends most of their time there. Show me what you're doing. Write a sentence. I'm solving for the time when the velocity is 0. I'm going to plug it in to the horizontal side. If you write that kind of stuff down, even if you run out of time, you have told the test grader that you understand what has to happen. That's far more valuable than being able to punch buttons in your calculator. What do I got? I got like 5 minutes, 6 minutes. You do need practice. That much is true. I didn't expect you guys to be excellent at this. We were just starting it, and it's such a small part. All of that stuff on the primer, you have to do that. Something rolling off a desktop horizontally, reaching the ground, you should be able to do all of that. Launch from the ground, landing on the ground, you should do all of that. All that stuff, you should be able to do. So if it's on the primer, I expect it. This stuff, there's going to be 1 on the test. You get 2 positive roots. If you were launching something from the ground and you wanted to land on top of, say, the roof of a building, well, it's plausible that you'll get 2 times. You're asking when the object is this high off the ground. And isn't it that high off the ground twice? Once over here on the way up, and once over here on the way down. So if you get two positive values, don't freak out. Understand that which one do you need? It's probably the second one. It's hard to land on the building when you're still going up, but it's easier to land on the building when you're going down. So it seems like the second one would be the more useful of the two values. So this is what is important to me, that you understand the meaning of what you get. If you can't get the time yourself, I'm sad. I'll smack your math teacher, but right now, we need to focus on what we can control in our room. Maybe something like this. Yes?
So for the initial velocity